Python has come a long way from its early days as a simple prototyping language. Today, it stands as a unified integration platform, connecting multiple physical domains, simulation tools, and advanced modeling environments. In this demonstration, we'll explore how the combined use of IVCAD Suite, CST Studio Suite, and Python brings this concept to life in a practical scenario. Imagine a smart factory filled with connected devices. A radio frequency signal is transmitted by the TX antenna composed of 4 patches. That signal travels through the environment and is received by another antenna with a single patch, the RX antenna. CST Studio Suite is used to simulate the antenna's performance and model the propagation channel between them. This channel is represented by an S5P file, which contains the S parameters describing the interaction between the 4 transmit patches, the receive antenna, and the radio link. Once this electromagnetic model is complete, IVCAD takes over. It uses the S parameter data to connect the wireless channel and the antennas to the RF front-end circuits, the power amplifiers on the transmit side, and the low noise amplifier on the receive side. Together, they form a complete macro model that accurately reproduces the nonlinear behavior of these circuits, even under complex modulated signals. From there, Python becomes the control layer. Through scripting, engineers can automatically adjust antenna positions, optimize configurations, or even perform system-level analyses, all within a connected, simulation-driven workflow. This seamless integration between CST Studio Suite, IVCAD, and Python paves the way for next-generation communication systems, smarter, faster, and more efficient than ever before.